Welcome. Today we discuss a new chapter, indefinite integral. We know what is derivative and how to obtain derivative of a function, we know it. But in integration, there is no definite formula for if a function is given, what would be its integration? That is not here. In fact, definite but indefinite integral is reverse process of derivative. That is, integration is reverse process of derivative. What is that? Now it means, suppose we know that ddx of say x square, we know that it is 2x. So integration of 2x, normally denoted by integration of function is 2x dx. Its derivative is 2x, its integration is x square. Moreover, we know that this function plus any constant c, its derivative is again 2x. Derivative of c is 0. So, in general, we say that integration of that is x square plus c. Normally, we say that c is integration constant. So, formulas, most of the formulas you know, or you can collect from any book, any standard book. I today mention here few formula which to be used in our classes. First of all, integration of dx by root over of x square minus x square. Function is 1 upon root of square root of s square minus x square, and it is equal to sine inverse x by a plus integration constant. Number 2, integration of that type dx by root over of x square minus a square, negative of that. It is equal to log of mod of x plus root over x square minus a square plus c. Plus c, it will be always we have to put plus c. Maybe I am not mentioning in next steps, I am not mentioning that c. Third one, integration dx by dx by x square minus a square. It is 1 upon 2a log of mod of x minus a by x plus a, obviously plus c. Third one is, the next one is integration dx by x square plus a square. It is equal to 1 by a tan inverse x by a plus c. Dx by a square minus x square. It is equal to 1 upon 2a log of mod of a plus x by a minus x plus c. It is actually integration dx in denominator is second degree, x square minus square, x square plus square minus x square, all these things, few are within square root and other is without square root. This is very important and we have to use this formula frequently here. So next. Now the same type almost, but in numerator, dx root over x square plus square, it is equal to x by 2 into root over of x square plus a square by 2 log of x plus root over of x square plus a square, of course plus c. Next one, root over of x square minus a square dx, it is equal to x by 2 root over of a square, oh sorry, is x square minus a square, x by 2 log of this one minus a square by 2 into log of mod x plus root over x square minus a square. In fact, in that formula, a square is replaced by minus a square, then we get the result. Next one, integration root over of a square minus x square dx, x by a into root over of a square minus x square plus a square by 2 into sine inverse x by a plus c. Okay, these are the 9 or 10 formula mostly to be used here. Okay, now for faster calculation, suppose sometimes dx by x minus a into x minus b. It is in fact of the type dx by, in denominator it is quadratic in x. It has a straight cut method, but here you see this can be written as only this thing 1 upon, not integration, 1 upon x minus a into x minus b, that can be written as 1 upon x minus a minus 1 upon x minus b. If I write what is there, you see denominator is LCM of this and that, so it is there. It is x minus b minus x plus a, so it is x minus b minus x plus a, so that they cancel. A minus b, a constant term appears here, so to adjust, so this can be written as always in that way. And what is the effect of that? What is advantage of that? Actually, it is constant. Integration of that is equal to integration of that is equal to integration of that. Now this is integration 1 upon x minus a is equal to log of mod of x minus a. Very easily we can do that. Similarly, that also we can do in this same way. Okay, next. integration of dx by ax plus b into cx plus d, almost like previous one. It can be written as 1 upon AD minus BC into integration A by AX plus B minus C by CX plus D dx. Here also you see same argument, denominator the LCM of this and that, it is there. In numerator ACX and minus ACX cancels and AD minus BC would be there. It is adjusted by that way. Now again, this if I can write this is equal to that, its integration is very simple, log of that. Its integration is minus log of that. So very easily this type of integration can be done without lot of time. Okay, next, another very important tips is that if an integration is of that form, integration u into v dx, where u and v both are functions of x only, then its integration by part it can be obtained, but ready-made formula is that it is equal to u into v1 minus u1 into v2. I explain it, plus u2 v3 minus u3 v4 plus and so on. So what is that? Actually u, okay, it is u intact. v1 is its integration of v with respect to x, integration of v only with respect to x. Next, u dash means derivative of u with respect to x once, and v2 is integration of v1 with respect to x. Here u2, derivative of u 2 times, that is derivative of u dash once. v3 is integration of v2 with respect to x, and so on. And signs are all signs, sign alternately positive and negative, and so on. For example, suppose we are given x square into e to the power x dx. Take this as u and this as v. What would be the advantage I am showing? Okay, it is formula is that u into v1. U means x square, v1 integration of e to the power x into the integration of e to the power x is e to the power x minus u dash derivative of that, it is equal to 2x into integration of that function e to the power x again, then plus derivative of this, it is simply 2 into integration of that e to the power x minus derivative of this, but it become constant, so its derivative is 0. So we can stop here. Otherwise, we have to integrate that function by part twice. So always you take EU, which is simply an algebraic function of x. Then after certain terms, it will be terminated by obtaining 0. One more formula. If integration is of that type, e to the power x into fx plus f dash x, result is e to the power x fx plus c. Once again I am repeating, if a function, but the integrand is of the type e to the power x fx some function plus its derivative. If it is of that type, dx. If it is of that type, its integration is simply e to the power x into fx plus c. It can be obtained after one or two steps by integrating this factor e to the power x into fx by part. And after first step, that factor will be cancelled. So, okay, with that knowledge, let us take few problems. The first problem is integrate x to the power 1 by 6 by x minus x to the power 5 by 6 dx. Find integration of that. So it is actually algebraic function. This numerator is algebraic, denominator is algebraic, and powers of x are different. One is 1 by 6, other is 1. 1 means 1 by 1, and third one is 5 by 6. All powers are fractions of that type. Its LCM of the denominators is 6. So if we take x is equal to t to the power 6, then very easily we can calculate that. That is one of the tips. If the functions are algebraic, in numerator and denominator, if all powers of x are of the type p by q type, then denominators, LCM of the denominators, if it is here it is 6. If it is 6, then put x is equal to some other constant to the power 6. If it is 10, LCM is 10, take x is equal to t to the power 10. After that, what would happen? Let us see. We have to change variable. We put here x is equal to t to the power 6. So that dx will be equal to 6 into t to the power 6 minus 1 means 5 dt. In that substitution, rather for that substitution, all powers will be integers. Okay? Because it is x to the power 1 by 6. X to the power 1 by 6 is t. Dx is your 6 t to the power 5 dt by x means t to the power 6 minus x to the power 5 by 6 t to the power 5. So that it becomes 6 can be taken common into t t to the power 6 by t to the power 5 into t minus 1 dt. T to the power 5 will be cancelled, so it become 6 into t by t, after cancelling t to the power 5 t dt by t minus 1, which is equal to t minus 1, and in numerator is t. Its maximum power is 1, and in denominator also maximum power is 1. So we have to divide them. Here, instead of dividing, we can simplify in that way: t minus 1 plus 1 by t minus 1 dt. So that this by that, it is simply 1. So integration dt plus 6 into dt by t minus 1. Now it is 16 plus 6 log of t minus 1. Now plus c. Now original variable is x, so we have to replace t in terms of x. So that t means x to the power 1 by 6. So that it is answer is 6 into x to the power 1 by 6 plus 6 log of mod of x to the power 1 by 6 minus 1 plus integration constant, and that is our answer. Next, the second problem is integration dx by x into square root of x to the power n plus 1. It is a very important type problem. In denominator, 1 is simply x, and other factor is within square root x to the power n plus some constant. In that case, let us see what is derivative of that. Derivative of this is x to the power n plus 1 is n x to the power n plus 1. So in numerator, x to the power n minus 1 to be present there. For taking, this is equal to z. So multiply x to the power n minus 1 in numerator and in denominator also. So it is x to the power n into root over of x to the power n plus 1 dx. This is n. Now put x to the power n plus 1 is equal to z square. So n x to the power n minus 1 dx is equal to 2z dz. We have here x to the power n minus 1 dx. It is equal to 2 by n, all are constant, 2 constant, n constant. So it is equal to 2 by n integration. This is, there together is 2z dz, 2 already taken. So z dz by x to the power n. X to the power n is z square minus 1. X to the power n, z square minus 1 into, this is square root of z square, that is z. Now z cancels, so that it is equal to 2 by n into dz by z square minus 1. So it is a standard form. So its formula is of this type dx by x square minus a square. It is 2 by n constant into 1 upon 2a. A is z square minus s square. A is 1. So that it is 1 upon 2a means 2 into log of mod of z minus a is 1 by z plus a plus c. So that now we have to change variable from z to the given original variable is x. So that 1 by n log of mod of z means root over of z is root over of x to the power n plus 1 z minus 1 by root over of x to the power n plus 1 plus 1 plus c. It is answer. Just 1 minute. I checked the answer. 1 by n log of okay. So in every problem I will supply you, I will give you the what to be taken, the I mean the tricks I will tell you. Tricks is here is that, and after that we will get one a standard formula, what I mentioned just before that. So every day you check the formula, see the formula, and this way after 2 or 3 days you will find that you can keep in memory all the formulas, and I will supply what would be the trick, how to start the problem and etc. Now here this is our answer. Next. The next problem is integration e to the power x into x minus 3 by x minus 1 whole cube dx. If in any problem, if you see that e to the power x is a factor, now then you will try to express this thing as what I told you earlier, e to the power x into fx plus f dash x dx. Then its answer will be simply e to the power x fx plus c, of course plus c. So let us try to express this as e to the power x is there, and this is equal to sum of two functions. One is fx, any fx, any function, plus its derivative, original function plus its derivative. So that it is, for that purpose, I can write it, you see, x minus 1 minus 2 by x minus 1 whole cube dx. So that it is equal to e to the power x. Now this by that, 1 by x minus 1 whole square, this by that, 1x minus 1 cancels, minus 2 by x minus 1 whole cube into dx. Now you see, if I consider, take this is as fx, its derivative is its derivative is minus 2, its power is minus 2. In denominator it is 2. Minus 2 into x minus 1 to the power minus 3, that is minus 2 by x minus 1 whole cube. This. So if we take this is as fx, then this is f dash x. So our answer is e to the power x into 1 by x minus 1 whole square plus c. Now you can verify your result. Integration of this, we claim integration of this is equal to that. So its derivative must be that. You differentiate and you get, obviously you will get, this is your answer. Okay, next. Next problem is integration dx by 2 plus x 1 plus x. So it is of the type dx by, in denominator two factors are there, both are linear. One is within square root and other is not within square root, that is it is simply a linear one. In that case you have to take the factor within square root. This is equal to t square or z square. Square because square root is there, so it will be more simple. You can take t also, you can take. Now convert from x to t. Differentiating this is equal to dx and it is equal to 2t dt. So now change here. Dx means 2t dt. 2t dt by root over of 1 plus x is root over of t square, means t. I put it first here. Then 2 plus x. It is equal to x and 2 plus 2. X means t square minus 1. That is, it is equal to 2 is constant taken outside. T cancels from there. Dt by t square plus 1. T square and they together is plus 1. Now it is of the type dx by x square plus s square. A is 1. Its formula is 1 upon 2 is constant. 1 upon a, that is 1 by 1 is 1. Tan inverse x by a, that is t plus c. Now from t to original variable, so 2 tan inverse root over of x plus 1 plus c. That is answer. Next problem. Integration dx by x plus x square minus 1. Here if we put x square minus 1 is equal to z square, because it is within square root, so it would be z. Then what would happen? Changing variable, its derivative is 2x dx is equal to 2z dz. Just 1 minute. Just I have copied. Oh, sorry. The problem is not that. The problem is it is x minus 1 within square root x minus 1. Two terms in denominator, both are linear, x and plus within square root x minus 1. This is linear, this is also linear. We put that factor x minus 1 as t square, z square, so that we get dx is equal to 2z dz. Now putting these values here, dx means 2z dz by x. X means x is equal to 1 plus z square, or rather z square plus 1, and plus this is x minus 1 is z, so that this is equal to 2 integration z dz by z square plus z plus 1. Now it is of the type, in numerator one linear factor in z, and in denominator a quadratic factor in z, quadratic in z. So this type of problem, numerator is linear in variable and quadratic in variable in denominator. In this case, we have to see what is derivative of the denominator. Derivative of the denominator is z is equal to 2z plus 1. So it is 2z is there. So I write it as, just 1 minute. This is equal to 2z plus 1. I write plus 1 and then adjust by z square plus z plus 1 dz. So that integration 2z plus 1 by, first time this by that, z square plus z plus 1 dz minus integration dz by z square plus z plus 1. Now first integral is always, it is log of that. Answer is log of that. Why log of that? Because if you take z square plus z plus 1 is equal to t, then 2z plus 1 dz, its derivative, actually it is ready. So this is equal to dt. So it is dt by t. Log t means it is simply, first one is log of, log of z square plus z plus 1 minus second integration, it is dz by quadratic in z. If any other constant is there, we can take it outside. So it is always, we can write it as dz by quadratic in z. Now try to make this as sum or difference of two squares. First one will involve z and second one will be constant. Before that, make sure that coefficient of z square become 1. If it is not 1, say 2, take 2 common from the denominator, 1 by 2 into that. So z square, coefficient of z square will be 1. Very easily we can do that. So it is equal to dz by, now try to make this as perfect square, then plus or minus some constant. It is actually z plus half whole square. Why? The z square product term is 2z half, means z plus 1 by 4. But I have 1, so that 3 by 4 is there, that is root 3 by 2 whole square. So that it is equal to log of z square plus z plus 1 minus. It is now of the type dx by dz here, dx by x plus a whole square plus b square. That is of the type integration dx by x square plus a square. Why x square? This plus some constant can be treated as it is as the variable one, or any variable z, because if I take this is equal to t, dz is equal to dt, dz is equal to dt, so that it is equal to dt by t square plus a square of that type. So it is equal to then minus dz by that, so that it is x dx by x square plus a square. So it is 1 upon a tan inverse x by a z plus half by root 3 by 2 plus c. Now we have to replace z in terms of original variable x. I have taken z square is equal to x minus a, so that it is equal to log of mod of z square means x minus 1 plus 1, the cancels, plus z means root over of x minus 1 minus 2 by root 3 tan inverse 2, tan inverse 2z plus 1 by root 3 plus c. So that this is intact plus this tan inverse 2z means 2 into root over x minus 1 plus 1 divided by root 3 plus c. And this is answer. Okay. Let us stop today. Next day, from next day, we will take some 5, 6 or 7 classes in indefinite integral. So next day we take some more problems. Thank you.